Okay, couple of things to um, talk about here. Uh, next week is spring break, right? So what we're going to do is we're going to do our midterm on Friday of this week. So you can take it during the normal class time if you want. Uh, so midterm, what's the date of that? Is that the 28th? 228. Everybody gets zeros. You're late. All right, so I'll put the midterm up probably by 8 a.m. that morning. I need it turned in by 5 p.m. that day so I can get the grades recorded um, before I'm out of town. Uh, I've changed the format on the exam this time from uh, to make it a little bit more uh, doable in the amount of time. So less coding on the exam, more showing competence in terms of knowing the ideas and also reading some code. So I might give you, here's code, tell me what this does. So there's going to be 20 questions. Short answer. Actually, let me do it this way. So multiple choice is new for me. Um, Fill in the blank and call it short answer when you have to like describe maybe what this code does or something like that. So there will be 20 questions each, 20 questions total, 10 points each. Um, and uh, you have and an hour and a half. I think I set the time limit for it. Should not be a time complexity issue. Uh, okay, so what I'll do is I'm going to go through just for a few minutes, go through the slides, point out the um, head the headlines of the things that I think are worth looking at to focus you in a little bit. Good news is I wrote this exam about an hour ago, so it's pretty fresh in my mind. So I should be able to give you hopefully decent hints in the direction that it's going.
How many questions then?
There are, but not yeah, not writing the code from scratch. You definitely need to be able to read code, and there's some questions that are coding, but it'll be like, what's the correct sequence of code to accomplish this task? And then it gives you maybe four options of approaches, and you can tell me which one is the right one. So still have to know how to code. Just yeah. For our time, it's more for time. Too many people had struggled getting stuff done in time last year, and I want you to be able to show your competence and it not just be a time problem. Okay, so let me start with um, so obviously, anything we've done up to this point from a coding perspective is fair game. And, for example, like you should know how to define variables, if statements, things like that, stuff from the previous course should already be in your wheelhouse. Chances are I'm not asking a question like, what is an if statement? But I will certainly have if statements in some of the code I might show you and things like that. So you should know what those things are. Um, let's see. You should definitely know what primitive types are, the kind of the concept of them, not so much listing them, not dealing with the number of bits for each one, but really like kind of the differentiating factor where primitive types are built into the language, you can only hold a value, whereas object types can do more. That kind of thing. Um, let's see. Definitely know what classes are, the collection of fields, methods, constructors, know what each of those things are, know about some of the special rules. Constructors have to have the same name as the class name, and it is case sensitive, stuff like that. be able to write, methods from the perspective of know that there's a return type, a list of parameters, that kind of stuff. Definitely understand the concept of a constructor and what they're used for, and how they differentiate themselves from methods. Let's see. Definitely understand static versus non-static, that concept. And that's both from the variable perspective, field perspective, as well as the method perspective. Understand pass by value versus pass by reference, how primitive types are passed versus how object types are passed. And when something's passed by value, what are the implications of that? When something's passed by reference or passed by address, what are the implications of that? Concept of blocking code. This is when we were talking about threads and stuff, when we want to have something go off and be worked on while something else is still going, which means we did not block, as opposed to if we have something, it's going to take 5 minutes sitting right here and it's blocking us from getting to the next line, that is blocking code. So understand that concept, and along with that, understand how threads allow us to do what we want in the event that we don't want to block. I don't ask anything about processes, so I focus specifically on threads, which is what we implemented in here. Nothing with that. So definitely know what a thread is up to a point. Keep in mind that the exam is an exam dealing with the topic of coding 2. Even though we did discuss things in here where it starts bumping in and intertwining with operating systems, important stuff, but you'll be tested on those things when you take the whatever it's called these days, the 350, it used to be 350 operating systems, whatever it is now. I think you'll probably take it next year. You'll be tested on the other stuff there. So if it's related to coding, that's where the focus is on in here. Interfaces to a certain extent. Remember, we discussed the runnable interface as it relates to threads, how the thread class implements the runnable interface. The runnable interface says there's a single method in there called run. Thread adheres to that interface. What's called implements that interface. And when we extended threads with our own classes, we then chose to override the run method that does nothing with our own run method. There is not stuff that has you deal with a lot of decision making about why would I have an interface versus not have an interface. So really understand just that concept that an interface effectively says, this is what it takes to be compatible with this type of thing. Certainly the idea of design patterns, just what that concept in general means. Definitely the singleton design pattern. You're going to be using that for the rest of your career. The concept of race conditions, not too deep, again, not into the operating system side of things, but kind of the consequence of race conditions as it relates to if we have two threads off and running, what happens if they're trying to access the same stuff. This would be another thing where, like, if we were in an operating systems class, this concept specifically of a semaphore locking and things like that would be fair game. In here, it's more of how do we programmatically handle race conditions. That was through that synchronized keyword. Obviously, you'll have to write merge sort by hand. All right, so actually nothing specific with merge sort, but definitely the concept of recursion. Understanding that there's consequences of recursion. Recursion isn't necessarily better than iteration, but that, a lot of times recursive functions are a little bit shorter, kind of like look fairly elegant, but there is a consequence of that where they use a lot of memory behind the scenes. And then I probably mentioned something along the lines of anything that you can do recursively, you could do iteratively with a stack, but we don't know about stacks yet. That's the next course, the data structures course. So I won't ask you about stacks is the punchline, but you can go your entire career always avoiding recursion if you had to. Okay. So basically this slide. Concept of generics, understand kind of the problem that they're solving. We didn't write any generics ourselves, even though they're not complicated. We've used other generics. So I think we saw it with array lists in here. And then we've also seen it in Unity being used with the component list that's part of our game objects. So this concept of generics, among other things, lets us avoid having to typecast stuff all over the place. We can create objects that can hold you can create array lists, for example, that can hold specific kinds of objects rather than generic objects, which then makes our lives easier when we go to take something out of that collection and we want to use it as the specific kind of object that it is rather than it be by default a generic object. Go ahead.
So with this, if you're just place something straight, that anything that gets put into that array
Well, anything you put into that array should. So the question for online folks was if you replace this E with like a string, he asked, is anything that goes into that array that will be treated as a string? I would say it's really the other way around. If you to build a generics with an E, anything you put and you decide that E is a string, anything you put into it better be a string because that's what it's compatible with. Therefore, anything you take out of it will come out as a string. It's doing that typecasting for you so that you don't have to have it come out of that collection as an object, even though you knew it was a string when it went in. When it comes out, if it's not using generics, it'll come out as like this. It'll be like it'll be your string, but wearing a costume. So it looks like an object. So Java won't let you start working with it as if it's a string until you convince Java that it actually is a string. And that's when we use typecasting, where you just put parentheses, string, parentheses before it. That can get pretty annoying pretty quickly if the common case for using collections like array lists would be to store one kind of thing. We can think a little bit in terms of our dungeon crawler, where we've already kind of discussed this idea of inheritance and things like that, where we maybe want to store anything that is a player, but maybe players come in two or three different flavors. That would be something where we might say, I want an array list of players, knowing that we might put wizards and warriors into that list. So when they come out, they'll come out as a player. Then we might still have to typecast them to wizard or to warrior, depending on what they were. So that's a kind of you have a container capable of holding the different types of players for that type of thing. But I would say the most common use of any of our collections would be to hold a whole bunch of the same kind of thing. A bunch of strings, a bunch of integers, a bunch of room objects, that kind of stuff. So the common thing would be make it hold the thing that you want to hold. So when it comes out, it's already that. You don't have to do anything special. Okay, but again, you won't have to write anything with generics because I didn't actually show you how to write your own generics. It's not difficult. Almost the same syntax actually, when you build your class. But we did use generics a little bit. Definitely the concept of model view controller, know what each of those pieces are. So view is our user interface, controllers are code behind, and even though we haven't worked with models yet, models are data. Okay, so if we needed to store stuff in between runs of our application, that would be what the model component is of model view controller. Understand design patterns are an idea, not necessarily an implementation. So different technologies you work with that support MVC would have different implementations of that. We've seen how Unity handles MVC by making our variables public in our code, which then exposes it to the view side of things. Other technologies do something similar, but might handle it in a different way. Um, I don't ask anything about factory, but definitely know about singleton and MVC. For your Unity, understand these primitives that are in Unity. Um, Less so of a scene. We haven't really jumped between scenes or anything yet, but you should certainly understand the concept of a game object, a transform, and to a lesser degree what a vector 3 is. We haven't really used them heavily, but the idea of storing either an X, Y, Z coordinate or just three values, that concept. The concept of a mono behavior. Um, Recently, we've been working with the difference between creating our scripts and either keeping the mono behavior on there or removing the mono behavior so we can have kind of just plain Jane C# objects for us to do other logic with. So mono behaviors are the things that we hang off of game objects, and now by making them a mono behavior, they now play by the rules of the game engine, which means the update functions getting called every frame or fixed update 60 frames a second. There's that start function that gets called once. Understand those types of things, that concept of a mono behavior. Concepts of colliders, the difference between a trigger and a non-trigger collider, whether physics actually plays a role in this or not. Um, uh, Related to that, the concept of a rigid body, how that would, if you want them to bump into each other and bounce off like physics said they should, there needs to be a rigid body involved. In either case, we could have code that responds to collisions, whether it was a trigger or another collision. So we can programmatically handle it, and we can also allow the game engine to visually handle the bumping into each other stuff for us. So understand the situation with colliders. Um, This is really that same question. Just understand that concept of our mono behaviors versus when we remove mono behavior from our class type in C#, we no longer have it extend mono behavior, what the implications of that are. It no longer is going to play by Unity's rules of the update method getting called and stuff like that. Now it's for us, the back-end programmer people, to start creating instances of our classes for maybe tracking stuff behind the scenes. And then there is one question dealing with our version control stuff that we talked about last class. So 5% of the exam is effectively last class. So free 5 points if you make sure you follow that stuff. So understand the difference between the underlying technology GIT, and the one of the use cases of it, which is GitHub, where we can distribute our Git repositories externally, as opposed to them just living on our computer right in front of us. Okay. The question I asked doesn't really have to do with the actual process of using GitHub. It's more of understanding what GitHub is doing. So it's not like I'm going to ask you what are the 5 things in a row you have to do to establish a Git repository or something like that, which used to be more interesting. Now that you just, with the Git desktop, you just say new repository. But you used to have to do like a git init and all this stuff to from the command line to make it work. Let's see. Okay, so that is effectively the test. Any questions about the format or anything like that? Go ahead. I guess my video lectures and these slides, or I don't know, Google and stuff if you need examples of some of the different things. So go back through our homework assignments, that kind of stuff. Go ahead. Yeah, so I think I have it set to open up at 8 a.m. on Friday. So it'll be when you go into Blackboard, it'll be under content. It'll say midterm exam. Um, as soon as you open it, you better be ready to finish it. You can't keep coming back to it and things like that. So it is likely going to take you less than an hour to do, especially since you're not having to do coding directly on it. So I would set, I give you an hour and a half. So set aside the hour and a half for it just so you have it. But I would be very surprised if anybody is going to need anywhere near the amount of time I set aside on it. Good. Right. We won't meet on Friday. So I 100% know you are all available during this period of time on Friday. So if no other time that day works for you, um, you can certainly take the exam during this period of time. Otherwise, if especially with it being about spring break, some of you might have already been planning some travel. Typically, the Friday before spring break is pretty spotty attendance anyways. Um, that doesn't mention the fact that I will also be on an airplane heading to Tampa, but let's just pretend that's not one of the reasons that we're doing the exam. That all right, but anytime you want during that day by as long as you get it in by 5 p.m. All right. Other questions? Okay. So let me, any questions on the online people? I'm actually paying attention to your chat right now if you happen to want to ask something. The online people get their questions missed often because I don't I don't see chat. Somebody has to unmute themselves and scream. All right. So how did the Git and GitHub thing go for oh, we do have a chat. Yeah, Caleb. So the same deal. Um, my policy in all my classes is if you do better in the final exam than you do in the midterm, I'll replace whatever grade you got in the midterm with what you got on the final exam. Not the other way around, though. You can't ace the midterm and then coast. You got to do well in the final anyway, you cut it. But if you have a bad day on the midterm, you can fix it completely with the final exam. Okay. So, how did Git and GitHub and all that jazz go for everybody? Pretty straightforward for the way we're using the tool. It does get significantly more complicated than we're using it for the second you start using that as a collaboration tool with other people, which is the real power of it. We are effectively using it as a convenient way of submitting your homework while being introduced to an industry standard tool. So you kind of get the best of both worlds. Good.
Oh, so like, does that instantiate that once you create the repository, or could you later like a Unity get ignored when you project?
Yeah. So the questions about the git ignore file, you can update or bring that file into existence whenever you want. You have the opportunity to get an initial kind of a template version of it when you're first creating your repository. There's kind of a common list. What you saw, there's like 80 things in there, right? There's like a common list of things, types of projects where they've already done most of the heavy lifting for you for deciding which files should be ignored versus which ones shouldn't. But at any point in time, you could create one without a git ignore and then just add that file later on. There's nothing special about it happening at the beginning. And remember, that's one of those files that has the little period in front of it. That's a hidden file. So remember, if you go and create that file, you want to make sure you create it in such a way that you are able to generate hidden files, which surprisingly is difficult with a lot of the GUI applications out there. All right, anything else? All right, so let's go back to our project. Let me just remind ourselves. Oh, by the way, my large language model did finally finish building after 13 days. The worst thing is when you get an error right at the end. Except usually you can pick up. No, you're not that far back because there's all these make files where it gets partially thing, but it did get finished building. So now I can run my own effectively chat GPT. Not quite as competent as the real deal, but whenever you put a response in, you usually get your answer within about 7 minutes. but it's all living on the machine. So it's yeah, it was a little celebration. But actually, it is an interesting thing when you consider um, our field, because like think about the amount of time that took to run on this computer, and even once it's running on this computer, it's still slow, right? You think about these online tools like, ChatGPT costs $20 a month if you want access to more of their models, whatever. And when you put a request in, you get a response like instantaneously. It's shocking how much power they have going on in the cloud from a hardware perspective. Because I mean, this is a M4 Max with 128 gigs of RAM. This is a legit computer that none of us would be happy with if that was our large language model we were working with. All right. So we last had a thing where we were kind of working with our back end stuff inside of our scripts folder here. Oh, this was our example from last time where I had that get text test thing. So I'm going to just delete that file. All right, so we have our room manager here, which we're using to communicate with our singleton. So there's not a whole lot going on in here right now. Big enough? The code, the core. Oh, that's it. For my project. It's inside the objects folder. Well, no, it is its own object. I just created a folder inside of scripts that I basically put all my stuff that are not mono behaviors just for my own thinking. Assigned a singleton to that. But like, here's my core. So, I mean, core is a normal C# class, and it's just filled up with a whole bunch of static things. Um, well, the scripts that are in our objects folder here in Unity are always active. So your anything that's a mono behavior, so like our room manager, this guy is a mono behavior, it only becomes active when you attach it to a game object. Whereas core or all our other objects like room and player and dungeon that we had in here. So here's dungeon. These guys are not um, mono behaviors. So you cannot attach them to a game object. You can drag them onto a game object all you want. It's not going to hook on there. Yeah. Because it expects it to be a mono behavior. A class like this, though, since it's filled up with a whole bunch of non-static stuff, wouldn't actually take up any memory until you created an instance of it. Whereas our singleton here, because, and we're calling it a singleton. Actually, if you've ever been introduced to singletons in other languages or seen something online, or maybe even saw some examples online, I make my singletons a little bit different than maybe a lot of built-in things. I think when we first introduced it, I probably mentioned this. A lot of singletons, what they do is they have a single static variable that is an instance of this class, and then you request from that singleton that instance, and you work with an instance that has all that information. The benefit of that is you can now pass it around, and you don't necessarily have to have it be public everywhere. You can have your singleton actually be private for most of the stuff, and then have a mechanism by which you can get at those variables. Whereas I think we're taking a more convenient approach, but it kind of is that antithesis of when we learned about like public, private, protected. And we said, oh, well, you should make all your fields and your objects private. Well, we made them all public here because we wanted to conveniently be able to access them. From my perspective, that kind of is acceptable given that we're already making a decision about I am storing stuff that needs to be conveniently accessed up in this global type place. So we're already kind of taking a risk, if you will, from a security perspective. So personally, I think this is the better implementation. of a singleton, and it's certainly easier to use. Kind of use at your own risk type thing. Behind the scenes, some people might make an argument of a performance difference between this and that, since based on the question that was just asked, this guy will always take up memory. He's always going to take up memory because he just exists, not in an instance form. The class just exists. So my feeling would be, you could say, well, what if I don't use the singleton? Well, then you probably didn't need one. So it's always going to take up memory as long as you're going to use it. Well, it wouldn't be there if I wasn't going to use it. So I expect it to take up some memory. But I guess take that or leave it. But from the perspective of that question, this class right here will always be using system resources, a little bit of memory. We're not storing a bunch of stuff here every single time we start our game. Whereas Dungeon would only take up any memory if we happen to have created an instance of it. And our mono behaviors only are taking up any resources if they've been hung on to a game object. And then they take up resources for every single game object that they're attached to. Each of those game objects gets their own instance of that particular mono behavior. And then it's be out of our control on how the game engine schedules our mono behaviors. You know, we put a whole bunch of stuff into like update in these guys. It's no longer in our control how the game engine decides to manage all the things it's supposed to accomplish every single frame. All we can do as programmers and say, oh, well, my room manager should be doing this stuff every update. And then we rely on the game engine to do that as efficiently as possible, whatever that ends up meaning for us. All right, so in our game right now, we have a single mono behavior, room manager, which I am pretty certain we just hung off an empty game object. So here's our room manager over here. We see it. Here's its transform just floating out there. Remember, the minimum viable game object exists in just a transform. That's all it has, but it will have. There isn't a such thing as a game object without a transform. It has to go somewhere. We're going to put it in our scene. But we just took that one transform that we never intend anybody to actually visually see. It doesn't matter where we put it in our scene, other than, you know, maybe you want to drag it off to the side so it's not an eyesore in our way of trying to grab other objects as we're trying to manipulate stuff. It does not matter where this thing is because we're not using it for a positional thing. We just hung a script off of it. So this guy wants our north, south, east, west door. In code here, inside of our room manager, we are keeping track of that array of doors. So we know that our room manager, an instance of room manager, will get created exactly one time. When our game starts and that room, I call it room manager, our room manager game object comes into existence, it will then create an instance of its room manager mono behavior script. And that's this guy. So inside here, we're keeping track of a field called the dungeon of type dungeon. And inside of start, we create an instance of that guy. So now we have an instance of dungeon floating around in here as well that's using up system resources, memory, and things like that. We're also creating our instance of player. We're storing it inside of the singleton so we can access it from wherever we currently are conveniently. Whether that turns out to be a useful idea or not, we'll see where we head, but that's what we did. So remember, start gets called exactly one time. So when our room manager first comes into existence, start will get called. We'll create our player, we'll create our dungeon, and we're going to go ahead and set our doors to be active or inactive based on what core currently has hard coded into it. We expect it's going to get better than this. but as of right now, we just are storing 4 variables inside of core that keep track of whether those doors are there or not. And we have defaulted to three doors being there and one door not being there right now. So our east door should disappear. If I go and run our game, we should see this door over here disappear. And if I go and change those booleans up at all, we'll see other doors appear or disappear. All right, so now what we want to do is we want to no longer operate off of those four hard-coded variables. Instead, we want to know what room is the player currently in and have this room up here like that room associated with what exits are available in that room. So if we go back to dungeon here, we see when we created our new dungeon, we created a whole bunch of rooms. We created a whole bunch of exits. Basically, this is the same code as we had when we did our, ooh, what? Nope. Dungeon only exists as an instance variable inside of this other mono behavior. So room manager is a mono behavior that keeps track of a single private variable called the dungeon that we brought into existence when the start function got called. So dungeon would not have an update method that gets called every single time, although we could do something to the dungeon every frame because we have access to it inside of a mono behavior. So our dungeon creates all the rooms, creates all the exits. That's where we're at right now. And then core also keeps track of our current player. All right. So now, as we have it right now, our room manager is the only guy that has the dungeon. Let's just keep it that way for right now so we can get some practice with what happens if something's in the singleton versus what happens if I have it in this single game object and that's the only guy who has the pointer to that thing. So what we want to do is we need to get the player into one of the rooms, right? Inside of Dungeon, if you went back and looked at our Java implementation of this guy, after we built the rooms, after we built all the exits, if we go back and look at a room, we'll remind ourselves that rooms hold on to a player. And a player, initially, when a room is first built, the room is empty. There's no players in that room. So we default the player variable to null. Now, in our game, when the game first starts and this room is taking on the form of the room the player is currently in, if we were to go to our player class, and players also know what their current room is, even though the value here is null, when the player is first born, we would probably set its current room to null to specifically say that here's the player floating out here in the void. All our rooms are out here floating in the void. And we're going to pick one of those rooms, I think probably R1, right? We're going to pick one of those rooms and we're going to put the player into it. Go ahead. Yep. Anything that's not a mono behavior is inside of my object folder. But you can put it wherever you want. Remember, folders in the asset folder for Unity are human eyes only. Unity's perspective is this is all just laying on the ground inside of your project. All right. So we have in our room manager, when the room manager is first born, we have created our player. We have our variable that accesses the player up there in our singleton, but the player now exists. So it's floating out there in memory. We've also created our dungeon. And when we created our dungeon, a whole bunch of rooms were brought into existence and a whole bunch of rooms had exits created. Now, these rooms are currently local variables only to this constructor. Which means that when this constructor is done, when the dungeon was done being built, automatic garbage collection is going to come and wipe all that away. So we no longer actually have our rooms. So let me do something and then ask you the consequences of this. So after I've created all my rooms, I've linked up all their exits, we probably want to go ahead and put our player into the very first room. All right, if you want your visual, here was our thing. We want to put our player right here into that very first room. We go and look at room. We see that room has a function called set player, where the player becomes aware of, well, the room becomes aware of that player. So inside dungeon, I'll go ahead and say R1 dot set player to core dot the player. All right, so this is happening inside the constructor for dungeon. Now, let's throw a curveball at you. Let's go back to room manager. Right now, I create my player first, then I create my dungeon. So this line makes that player appear up in my singleton. This line brings the dungeon into existence. What if I built the dungeon before I built the player? What's the consequences of that little decision in our current code? Go ahead. Well, so since when we call our constructor for dungeon, the player is not set. We know it's not set. It's possible that it could have been set somewhere else in our project, but it's not, right? The place where our player comes into existence is right here on line 12. But on line 11, excuse me, on line 11, we're building our dungeon. And after we built all those rooms and stuff like that, we then say, room 1, I want to set the player to whatever the value of core dot the player currently is. And right here, what is the current value of core dot the player? Given the fact that we are building our dungeon before we're building our player. What's the current value of core dot the player? Right here. I don't, it doesn't matter. When you get to this line, when we get to this line, our player doesn't exist. You know. Now, is that going to be a problem? Is this going to cause the program to crash? Well, we can't answer that without looking at what happens. What would happen if I passed a null value into set player for my room? Let's go to my room, look at set player. Just going to set this room's the player equal to null, which is actually what it already was. Not actually a problem. This isn't going to crash, except for the fact that maybe what we thought we were accomplishing isn't what we actually were accomplishing. Okay, so kind of the lesson here is as you're starting to build more and more complex applications, things like order do make sense or do matter. It is very important for us in this case to not build our dungeon until after we've brought our player into existence, since the process of building our dungeon relies on the existence of the player. All right, that's something we have to keep track of as the programmers, because that would be a bug that might be difficult to hunt down, especially if you do too much of your project at once without testing. So another lesson here. Don't write 5,000 lines of code and then sit down and test it, forgetting what you did 7 hours ago. That is the problem right now, but it's not an obvious enough error that it's going to pop into your head. Test often to make sure what you're trying to accomplish is what you just accomplished, so you have a level of confidence there. I know we're down to 2 minutes. Got it. So, create our player. He lives up in the singleton. From this point forward, we have an actual player. Create our dungeon. dungeons being created. We have all our rooms. The rooms have a bunch of exits. I then set room one's player to the player. So room one right here now has its player in it. When we get to line 13 here, what's happened to all our rooms as it stands right now? They're all gone. They were all local variables of our dungeon constructor. If I go into room, when we set the player for a room, if you remember back to the way we did this in Java, the room also let the player know about itself. So if we go to player, we see player has a set current room. So we can say this dot the player, or we can say core dot the player. This dot the player currently exists because we just set it. Dot set current room to this. By doing that, my rooms are now preserved. Why? Because my player knows about room R1. R1 knows about R2. R2 knows about R3. Yeah. R3 knows about R4, R5, R6. So there's at least one pointer still in existence that points to all these rooms, even though those local variables died. We still maintain the memory addresses. All right. So no homework. We'll come back on Wednesday. We'll keep trucking here. Make sure you're preparing for the midterm. Remember, we will not meet for class on Friday. We will meet for class on Wednesday. Okay. Friday, you'll have class time to do your exam.
Question about